everybody, and thank you for joining us today for Vertica Unified 2021. Today's breakout session is entitled Integrating Kafka with Vertica for Real-Time Data Loading. I'm Jeff Healy, and I lead marketing at Vertica. I'll be your host for this breakout session. Joining me is Pravesh Bhardwaj from the Vertica Solutions Architect team. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait, just enter your question in the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to gain points to participate in our Analyze to Win competition and win prizes. Now let's get started. Over to you, Pravesh.
Thanks, Jeff. Hi, all. My name is Pravesh Bhardwaj. I'm one of the pre-sales solution architects here at Vertica. And today I'm going to talk about Vertica's integration with Kafka, some details, how-tos, and finally the best practices. So before we dive into Vertica's side of things, let's do a very high-level overview of what Apache Kafka is. So Apache Kafka is an open source product which started at LinkedIn. So it's a pub sub messaging system. It is also often described as a distributed message bus or event log. So we have systems known as producers that produce new records, records which are immutable and appended with an offset at the end of the log known as topic. Then consumers or subscribers, they consume these messages. Messages are persisted to disk, and where retention policy determines how long they are stored. This retention policy is defined either in terms of period of time, which defaults to 7 days, or the size of the log before older messages are automatically deleted. So looking at the architecture of Kafka, so Kafka comprises of a Kafka cluster, producers and consumers. And a single Kafka server in Kafka cluster is called a broker, with redundancy being provided by multiple brokers within a cluster. Kafka topics are divided into a number of partitions. Partitions allows us to parallelize a topic by splitting the data in particular topic across multiple brokers. In other words, each partition can be placed on a separate machine to allow for multiple consumers to read from topic in parallel. Consumer groups or the group of applications that consume these messages, they keep watermark of offset consumption per consumer group ID. So in a way, broker's role is to receive messages from producers to which it assigns offsets and committing messages back to disk. Broker also responds to fetch requests from consumers and delivering messages back to them. Now, with this brief overview of Kafka, let's dive into Vertica and Kafka integration. So Vertica provides a highly performant mechanism for consuming, storing, and analyzing streaming data. Vertica can also act as a producer, with data being sent to Kafka topics, which can then be consumed downstream by applications that can read data off the Kafka message bus. When it comes to consuming data from Kafka into Vertica, there are two ways that this can be achieved. One is the manual load mechanism, which is performed by using the SQL copy statement. So if you have used Vertica, you definitely know what a copy statement is. And this manual method allows us to load a finite amount of data from Kafka. The second method is the automatic load mechanism via a scheduler and is configured using a tool called vconfig that comes bundled with the Vertica distribution or Vertica RPM. The scheduler has a number of advantages over manual load process, including continuously loading data from Kafka and ensuring that each message is loaded exactly once. Now, if you look at this diagram from Vertica's perspective, there are two important pieces in this picture, Kafka UDX plugin and Kafka scheduler. Kafka UDX library contains the functions that load and parse data from Kafka topics into Vertica. And The Kafka scheduler uses a UDL or user-defined load library to continuously consume data from your message bus with exactly one semantics. And there's more. So Vertica's Kafka scheduler also supports Confluent schema registry for Avro schemas. So if we use Kafka Avro parser, it can use the schema registry to parse and decode the messages. Also, data communication between Vertica, scheduler, and Kafka can be encrypted with TLS or SSL. It can also be used to verify the identity of all the parties involved in data streaming. So we use simple authentication and security layer, also known as SASL, to authenticate Vertica with Kafka. And for this, Vertica supports using SASL underscore plain text and SASL underscore SSL protocols. So after covering these components that account for Vertica and Kafka integration, let's first look at the cases where how Vertica acts as a Kafka producer. So I mentioned earlier that Vertica can act as a producer and consumer both. So to understand more about Vertica's use as Kafka producer, it can be done by using this function called KafkaExport. And using KafkaExport, Vertica can produce data to a Kafka topic, and which then can be consumed by any other applications or Kafka consumers. If you look at the syntax here, the parameters or the options it takes are the partition column, which is the partition of the Kafka topic, and then key and the value columns as well. And then it follows with the obvious configuration to identify Kafka broker to Vertica. So we specify the brokers, we specify topic name, etc. This value column can be any string of text. The example you see on the right, it formats this message as a JSON message. And lastly, one of the options in the Kafka export shown here is called Kafka underscore conf. So this is a special parameter. So it can be used to pass configuration options directly to RD Kafka library. So this is the library that Vertica uses to communicate with Kafka. And we can use this parameter to directly set any configuration options that are not available through Vertica's integration with Kafka. So if we look at the example on the right, so what we are doing is that we are setting the partition to null, and in which case Kafka will use the default partitioning algorithm. Also note the casting we are doing for ID column. This is also important because Kafka export expects the ID column to be a character. And finally, we pass the JSON value for second parameter or the value column. And one of the important points about Kafka export function is that if there are any records that are rejected during the export, they are returned by this function. And that's would explain that what we are doing here, we are saying insert into a table and then the select Kafka export function. So if there are any rejected records during this Kafka export, they will be returned by function and will be stored in this table Kafka rejection that we can review later. And the second option to produce data from Vertica to Kafka is known as Vertica Notifier. So Vertica Notifier is a mechanism to send primarily Vertica's diagnostic data from the data collector tables. So if you've used Vertica, you know that we have these special tables in Vertica. We call them data collector tables that store Vertica databases real-time monitoring information. So using Notifier, we can directly publish messages from Vertica to Kafka, and Notifier can also automatically send messages when a component in the data collector table is updated. So I'll talk more about this on the next slide. So the idea and the configuration is pretty straightforward. We create a notifier and we pass values like details about Kafka broker, the maximum memory size that this notifier can have. The limit is 2 terabyte. And then we also can assign an unique identifier to a Kafka notifier. So in this case, we say identified by DC notify example. And once the notifier is defined, we call this function notify. And this is a pretty straightforward example where we say notify, we pass the message to be sent to Kafka, then the notifier name and the destination Kafka topic. So this is how we can use notifiers manually. But as I mentioned that the special use of notifiers is within transferring the monitoring information from Vertica to Kafka. And this is the most common use case that we have. So the problem with Vertica's data collector tables is that they have a defined retention policy, which can be based on time and or size. But yes, the retention policy is limited in most of the cases. So using the notifiers, the management console uses this mechanism to provide extended monitoring so that data from DC event history can be preserved on an external database that management console can display as part of its reports and dashboards. And this can be achieved by using this function called data underscore collector underscore notify underscore policy. And the use is again straightforward. So we specify the DC component name. So if you know about DC tables, so we know that each DC table belongs to one DC component. So we specify DC component, we specify then notifier name. Third option is the Kafka topic, and then we enable this collector notify policy. So that's how Vertica extended monitoring uses Vertica notifiers to stream data from Vertica to management console database using Kafka. Right, now look at how Vertica acts as Kafka consumer. So to understand Vertica's role as Kafka consumer, we need to understand about KafkaSource, which is an inbuilt UDL to load data from a Kafka cluster into Vertica. So whenever we are copying data from Kafka to Vertica, the source of the copy statement always has to be Kafka source. And if you look at the syntax to define a Kafka source, the first parameter stream is where we define what data needs to be loaded in the form of Kafka topic, partitions, and start and end offsets. We can also specify the number of threads that will be used when loading data, and this is done by specifying the value for execution parallelism. And normally this is set as an integer value between 1 and the number of partition that node is loading from, Kafka topic partitions. So if you look at the example on the right, it uses Kafka source to load data from Kafka into an existing table named web underscore test with the following options. So stream is a named web underscore hits, which is the name of the source Kafka topic. And it has a single partition. And if you take a note of the second option, we say 0. So this is the partition 0. The load starts at the earliest message in the stream. And this is identified by passing -2 as the start offset. And then finally, the load ends when it reaches the message with offset 10,000. The Kafka brokers are identified as Kafka 01 and Kafka 03. And then we specify the port that the brokers are listening on. And finally, the parameter stop on EO of equals to true. So it has a special meaning. So if you look at the target offset, we specify this as 10,000. So what it means is that the load will end if it reaches the end of stream before reaching the message with offset 10,000. If we don't supply this parameter stop on EOF, so what it means that in that case, connector will wait until Kafka sends a message with offset 10,000. And finally, the data is sent to Kafka JSON parser for processing. In terms of the Kafka parsers, we have three options. One is the first parser is it's called Kafka Parser, which actually doesn't really parse Kafka messages. It simply passes whatever messages it receives as a long varchar to Vertica. And then we have Kafka JSON parser and Kafka Avro parser, what we see here on the screen. Especially for CSV data, there is a very important parameter that we need to specify. So we need to insert a delimiter between each messages. So this is what we do by this filter Kafka insert delimiters, as you see in this example. If we don't specify this parameter, then it will be like processing a CSV file without any new line characters or carriage returns. So we see here all the options that Kafka and Avro parsers can take. Functionally, they're not very different from the Flex parser, with the difference that Kafka Avro parser can leverage schema registry, and both Kafka and JSON parser can handle continuous loads, which is the requirement for using Kafka as streaming data source for Vertica. Now that we have seen how Vertica acts as producer and consumer for Kafka, let's dive into some details about Vertica Kafka Scheduler, because this is what that makes the streaming data load from Kafka to Vertica possible. So we'll break things down. We'll look at different components of this use case. So we'll understand more about Kafka UDX plugin and how we use microbatch commands to load chunks of data from Kafka. And then finally, how do we define and manage scheduler, and how using scheduler we can not only implement the continuous exactly one streaming, but also how we can dynamically manage the resources between different topics and different streams that we load data from. So let's look at some of the terminology first. Some of these we've already discussed, some are new. So topic or source we know it is Kafka topic. Partition is Kafka topic partition, which is a unit of parallelism in data streaming. Message is the unit of data that comes from these topics, and generally the data is in JSON or Avro format. And then finally, these messages are identified by their source, partition, and offset. Scheduler is an external tool, as I mentioned earlier, that enables or schedules this streaming load from Vertica to Kafka. Then we define microbatches, which is a single unit of data load from Kafka to Vertica. And also microbatch includes or encompass all the information that the scheduler needs to load data from Kafka into Vertica. Frame is as interval or window of time during which scheduler executes these microbatches. And finally, lane defines the concurrency of the parallel data loads. And this is eventually translates to the planned concurrency of resource pool that we use for our Kafka scheduler. Right. So before we actually look at how do we create and maintain schedulers, let us first look at what a scheduler is designed to do and some of its components. So this all encompassing scheduler is responsible for scheduling the loading of data from Kafka to Vertica. And within the scheduler, there are a number of individual components. So let's start off with the clusters, which define the details of Kafka cluster and its broker from which data will be loaded. Then sources define the source Kafka topics and their partitions. Then targets, which translate to target Vertica tables and schemas. And then load spec defines some of the settings that are used by Vertica to load data into from Kafka to Vertica. And finally, the microbatches. And microbatches then eventually combine the definitions of cluster, source, target, and load spec, and then form an individual streams of data from Kafka to Vertica. The scheduler is then able to manage these microbatches to copy data from Kafka to Vertica using KafkaSource UDL, as we talked about earlier. And what we see on screen are the internal SQL statements issued by our scheduler. So the stream microbatch history table, it stores the state of each microbatch about what to do next. So this is where we frame a bootstrap so that scheduler knows from which offsets we need to get data next from a given topic. Then comes the actual copy command or the actual data load statement. And it has details like KafkaSource, which I mentioned earlier. It tells us where the data will come from and what parser to use. So in this case, we are using Kafka JSON parser. And please note the the option no commit. So it means that when this copy will execute, it will not commit the data yet. And that is important because in the next step, we store the offsets of this last copy command into stream microbatch history so that we know where do we need to start from during the next run. And once all this is done, then the changes are committed. And as you can see, the commit is at the end. So this is an atomic operation. So it's all or nothing. And that's how we are able to achieve the exactly once delivery of Kafka messages to Vertica. In terms of managing and creating the scheduler, it can be done by using vconfig script. And vconfig script is installed along with Vertica. It comes with Vertica RPM, and it is used to create, configure, and run schedulers. So in terms of steps, so these are the steps we need to take to define a scheduler. And some of these steps can be, let's say, performed in a different order. Some are optional, and some can be even reused across schedulers. But if we are setting scheduler for the very first time, this is the typical order that we take. So it all makes sense. What we saw is that we define things like we create a resource pool, we create scheduler cluster, and a data source, data target, and then finally load spec and microbatch, and then we launch the scheduler with all this information. So to do this, I mentioned that this vconfig script is installed as part of Vertica, and it has a defined command line interface. And important thing to understand is that all the configuration and even the runtime state of these components is stored inside Vertica database in a different in a particular schema. So if you look at these steps on the bottom, they actually relate to what we saw on the previous screen. So we create individual components like scheduler, cluster, source, load spec, target, and microbatch. And then with all this information, we finally launch our scheduler that starts the continuous loading of data from Vertica to Kafka. All this information, so we have seen so far how Vertica acts as both producer and consumer. So what options, what functions we have. Then we know how do we create and manage schedulers and what scheduler does. So with all this configuration ready, but this let's say step before we actually go and stream data from Kafka to Vertica is that we should go and do some basic checks. For example, let's start with the connectivity. So first we need to establish if Vertica can speak to Kafka or talk to Kafka. So we have, for example, several ways. One is the Kafka Cat utility that is bundled with Vertica as well. We also have this function called Kafka check brokers. And this function, when we call this function with the Kafka broker URL, it tries to communicate with Kafka and give us in the output all the brokers and their ports and all this information. If we want to use SSL or TLS with Vertica, then this is the time to make sure that we check certificates, we check OpenSSL, and we can also use, of course, use Kafka Cat utility for this purpose as well. And again, if you're using authentication as well, then we check if these parameters SASL plain text or SASL SSL, they are configured correctly, and if they work as expected. In terms of message format, so yes, before we start loading, of course, we need to determine what format our data comes in. And it's sometimes may not be a choice to make, but yes, if given a choice, generally CSV is faster than JSON, and which is faster than Avro. If our data is in Avro, and if we are using Kafka Avro parser, then and if we need schema registry, then this is the time to check the access to registry as well and check schema versions. We can also do a small data load, a very simple copy command with a very small number of messages, and then if there are any errors or issues during copy command, then we can check the errors, parsing errors and data from the rejection table. So in this example, we do a simple ingestion test. So in this case, we are loading only 20 messages per partition. So it's a simple manual copy. We specify the stream. In this case, we are loading from topic IoT and partition 0, 1, and 2, and start and end offsets are 20 and 40. So if this copy command executes successfully, then we can run this function Kafka offsets, and it gives us details about the data that was loaded in this last copy command. So with this small check, we can make sure that all the configuration we have defined works fine. The connectivity between Vertica and Kafka is in place. Right. Another important consideration is, do we really need exactly one processing when we are talking about moving data from Kafka to Vertica? Because if this is not a very strict business requirement, then it simplifies things a lot, and we can actually avoid a lot of complexity. So what we can do in this case is that we can simply manually copy data from Kafka, and we can do a tight loop using KafkaSource. And in terms of offset, we can rely on consumer group ID's watermark. So this target offset of -3 has a special meaning. With -3, we are actually what we're trying to do is that we are getting the data from consumer groups ID's last watermark or last offset. So this makes things quite simple. We can run these copy commands manual, and it saves us from a lot of, let's say, configuration and management of schedulers. In terms of parallelism, because generally in a production system, there will be a large number of topics and partitions. And how things usually are is that every topic will go to a different target table unless the message format is exactly the same across all the topics. But if this is not the case, we probably will be dealing with a number of different topics, and each topic can have a number of partitions as well. And we will see shortly how this number of partition eventually relates to how many parallel threads Vertica copy can run or should run. So what what we need to consider is that if all these partitions have high throughput, and given the parallelism boundaries, if Vertica cannot process all these partitions, it helps to use separate copy commands, and with each copy command targeting a subset of partitions. Because if we don't do that, it's quite possible that what we lag behind in terms of the consumption of messages, especially for high throughput topics. Another option could be to use different schedulers for different throughput topics. So idea is that you will always have topics where some topics they produce messages with very low throughput, some are very high throughput. So using one scheduler for all the topics may not be very optimal in some cases, given the fact that the frame duration is defined at scheduler level. So sometimes it makes sense to use different topics, and then we can, let's say, group the topics into a different scheduler, for one for, let's say, high throughput, one for low throughput. And that's actually enables us to use the frame duration optimally for different kind of use cases. In terms of the parallelism, there are few more considerations. So for example, if we are using scheduler, the planned concurrency, it defines the number of lanes, or in a way defines how many concurrent copy statements Vertica can run. Execution parallelism defines or determines how many partitions one copy command can consume in parallel, and that eventually depends on, or let's say in a way decides how many parallel threads each node will create to consume data from partitions. And generally, one thread equals to one Kafka partition, so in a way that Vertica uses one thread to consume one partition. So what that means is that if we have too many partitions for a topic, and if Vertica assigns a thread for each of the partition, So we may have a case where we have more partition that Vertica can consume data from parallelly in parallel. If we talk about some of the best practices about schedulers, so there are a few things that we need to consider. First thing is that we always recommend to create a separate resource pool for Kafka schedulers. And for this resource pool, these are the parameters that are most important. So I mentioned earlier that execution parallelism decides how many threads Vertica will use per copy statement. Planned concurrency means how many concurrent copy data load commands will run. And the expected number of partitions per microbatch. So we define so I mentioned that frame duration is, we define at the scheduler level, and this is, so so we define a frame duration, let's say 5 minutes. And how scheduler works is that each microbatch defined for a scheduler, it gets a slice of this time. So in a fair but a dynamic fashion. And what do I mean by this? I'll explain shortly. So what we need to consider here is that we need to make sure that the frame duration is not too short. And if you're using Vertica 10.0 or 10.1, we do have certain warnings in place. If, for example, frame duration is less than 2 seconds, then Vertica gives a warning that probably this is too small. We also need to make sure that frame duration is not too long, because that will be also will not be very optimal, depending on how good or bad the throughput is for a given Kafka topic. The idea eventually is to find a balance. So we always recommend that to start with a reasonably long frame duration, and then probably adjust it as we go forward depending on the throughput that we receive. In Vertica 10.x, we set a 5-minute default. And finally, as I mentioned earlier, that using different schedulers for different latency needs for topics with high and low throughputs, it can be a good idea as well. So if you look at this figure, so this shows us what a scheduler does in a given frame. So the first figure, it shows that for a given frame, we do some sort of startup routines. Then the rest of the time is dedicated to execute the microbatches. And even inside a microbatch, there will be operations like starting the transmission. Then yes, the most of the parts should be used for executing the actual copy, but this is not what the all the frame duration is used for. So if we specify, let's say, frame duration of 10 seconds, not all the 10 seconds are used to load data from Kafka to Vertica. So how it works is that in this case, let's take an example that for this scheduler, we have 4 microbatches. And in the first frame, scheduler will assign equal amount of time for each microbatch. So in this case, each microbatch starts with a similar time slice. But yes, individual microbatch can take different times depending on the data that they're trying to process and load into Vertica. So in this case, microbatch 2 takes the longest, and microbatch 3 takes the least amount of time. So how scheduler works is that during the next frame, it will try to start with the microbatch that took least time. In our case, microbatch 3, then microbatch 4. So that remaining time can be assigned to microbatch 2, or the microbatch that used most of the time last time around. So that's why I said earlier that it's a quite fair, but this slicing or the slice distribution is dynamic, and it depends from between different frames. And this is the similar thing, but with a very specific example. So in this case, let's say we have 40-second frame duration, and we have 4 microbatches. So each microbatch will be assigned 10 seconds initially. Then during the step 1, we see that microbatch 1 finishes in 4 seconds. So remaining 6 seconds from microbatch 1 are then equally distributed to microbatch 2, 3, and 4. Then in the step 2, microbatch 2 finishes in 10 seconds. So the remaining extra 2 seconds are then distributed on microbatch 3 and 4, and so on. Then finally, we see that in this step 4, microbatch 4 finished in 2 seconds. So when a scheduler starts the next time, it will probably start with microbatch 4, which use the least amount of time, then microbatch 1, then microbatch 2, and then microbatch 3. So we saw how within each microbatch, Vertica tries to load data from the sources that we define from individual topics and partitions. So there can be situations where, especially with topics with high throughput, that either the microbatch duration is too small, or there are in fact a lot of partitions to read from, and that eventually means that sometimes Vertica may fall behind the consumption of these messages to Vertica. So in these kind of scenarios, we have an option to set the max parallelism setting in vconfig, and what it does is that it will split one copy command into multiple copy commands of equal size subject of topic partitions. So let's see an example of how this works. So let's see this scenario where in this case we have planned concurrency 2. So what it means is that a scheduler can actually have 2 concurrent microbatches running. In this case, we have only 1 microbatch running. So that's why this 1 slot is not used right now, the one that you see on the shaded gray color. And execution parallelism is 2. So what it means is that each node will create 2 threads to read data from individual partitions. So in this scenario, we have 1 slot, or let's say 1 slot free, and we have the bandwidth in terms of the resources we have. So if we use max parallelism equal to 2, so what Vertica will do, Vertica will actually split this into 2 different copy commands. And for the second copy command that will load from the 4 partitions, it will use the second microbatch, and then now we can have 4 threads running in parallel at a time, even when the execution parallelism is 2. So in a way, we are splitting microbatches so that we can run more concurrent copies, and each copy targets the subset of partitions in this case. And that, as you would imagine, helps in these scenarios. Right. In terms of where and how to run scheduler, because scheduler is an application, and you would imagine that it may take some resources, and it might compete with the resources in a Vertica database. So scheduler is actually a Java application. It works on JDBC, and we can run scheduler on a system outside Vertica cluster. It doesn't necessarily have to be Vertica node. So, but yes, the resource requirements are pretty small. So we have customers who run schedulers on very small machines or VMs. If we run scheduler on an external system, of course, it doesn't affect Vertica operations. And the only downside is that when we upgrade Vertica, we need to upgrade the scheduler separately. So if you remember, I mentioned earlier that scheduler is part of a Vertica RPM. So in this case, we need to make sure that we upgrade Vertica version on this box as well, where we run Vertica scheduler. In terms of monitoring ingestions, so I mentioned earlier that for each scheduler, Vertica creates a number of system tables in a schema which is named same as the scheduler name. And one of these tables is stream underscore microbatch history. And as you probably the name suggests, that it stores all the let's say runtime information or historical information about microbatches and defined for the scheduler. So in terms of monitoring, we can use this table to check if the messages that have been ingested or loaded so far, if they're load balanced or balanced across partitions. This is a simple SQL. We can check this. We can also check if any partition is falling behind. In this case, you will see the reason as deadline. So we are seeing the end reason for our microbatches, and that should give us an idea if this is the case. Vertica's management console also has a very, let's say, quite a useful interface or view. So it lists all the defined schedulers and the microbatches, and we can not only see the real-time information, like how they are working, how much data they have loaded, but we also see if there has been an issue, if the scheduler is stopped, or if there was any error or something. If you're using consumer groups, Kafka tools can be used to monitor offset leg per partition. So Vertica does not actually rely on Kafka's consumer group, but yes, for we do update, or Vertica do update its end offset to the Kafka consumer group. And in this case, any end application or Kafka tools, they can see the status or progress of Vertica data loading using Kafka consumer group script. Right, and this in fact brings me to the end of my presentation. So I will be happy to take any questions now and discuss with you. And so thank you all, and over to you, Jeff.
Thank you for listening to our presentation. Now we're ready for Q&A. Pravesh, great presentation. Let's dive into some of the questions that have come in.
Sure,
All right,
Jeff.
we've got one here. Yeah, sounds great. What are some important resource pool settings for Vertica Kafka ingestion?
Right. So yes, I think a couple of parameters that we discussed during the presentation as well. The first would be the planned concurrency of the resource pool, and that will actually govern how many micro batches we can load in parallel. So planned concurrency is very important. And second would be the execution parallelism, which will govern how many threads a Vertica node will create to load the partitions from the topic. So these two are the most important, I think, the configurations that we need to probably take care about. And yeah, and probably one more thing is queue timeout, because for Kafka we want the scheduler to manage the timeouts and executions. So we recommend queue time to be 0 in case of the Kafka scheduler or the Kafka resource pool.
Got it. Very detailed, Pravesh. Thank you. Perfect. We got a bunch of them that came in, and again, we'll answer those that we can't get to. We run out of time. There was one on any idea of the volume that can be handled with real-time Kafka. Do you speak at all to volume?
I cannot really recall the number, but that famous case study we have with Facebook and sorry, the one with Vertica, I think that was pretty huge. I think if you
It was, yeah.
recall the number, yeah. So I
I
think it
don't know.
was,
We can get those though.
yeah. So yeah,
A
for
lot of
that we did
messages.
use Kafka to load data into Vertica, yeah, and it was pretty huge.
Okay, great.
Yeah,
We'll make sure we get that out to you
yeah,
for that
of
attendee.
course. Yeah,
Got another one here. Does
yeah.
Vertica/Kafka integration work with Vertica in Eon mode the same way as Vertica in enterprise mode, or are there any differences? It's a common question.
Absolutely the same, and that's the thing, that Vertica as a product is same, so whether we run in enterprise or Eon. And so in terms of functionality and how it behaves, it's absolutely the same. The only I think point I would like to mention is that with especially with Vertica Eon running on cloud, we need to probably have some consideration towards the network latency. Generally, latencies tend to be higher on the cloud, so that will be an important factor when you decide your frame duration for the scheduler. So, but yes, apart from that, there is no difference in terms of functionalities and what we support and what we not. Yeah.
Gosh, thank you. Yeah, there's one here, and see if you have more details. It's around the scheduler. So it's how can Vertica produce the messages without scheduler? messages need to be produced as and when the rows are inserted. So maybe just with scheduler, without, do you know, have any details around that?
So if I understand the question right, we're talking about producing messages out of Vertica. So it's Vertica to Kafka, right?
I believe so, yeah, because it's a follow-up as messages need to be produced as and when the rows are inserted. So it's going in, I
Right.
guess.
So I think we have something similar. So I talked about the notifiers and how we use notifiers to export data from Vertica DC tables, but I'm afraid that use case is very limited to the notifier part and that associated function only for DC tables. So if we talk about the user tables, I think we don't have anything out of the box, so that was whenever new data comes in, we export that to Kafka. But yes, we can always use Vertica's KafkaExport function and probably write some utility that will periodically export data from user tables to a Kafka topic. So that is definitely doable. But yes, it will require some custom development to probably schedule that in some way.
Thank you to our audience for your great participation. If we weren't able to answer questions today, we promise we'll do our best to respond directly via email. And again, go to the Developer Lounge. That's where all of our engineers are. You can ask those questions there as well. Please note that a replay of today's event and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type the session code in the Analyze to Win section on the event navigation panel. And note that there will be a short message from our sponsors that I encourage you to stick around and catch. Our sponsors are super important to us and really help build out our ecosystem. I'm sure you'll enjoy it. And now this concludes this breakout session. Have a great day. We hope you enjoy the rest of Vertica Unified 21.
We are at the age of data. Enterprises today still struggle to solve problems of the past. There are tons of commoditized solutions with lack of identity and value in the market. In Global Maximum, we do not believe in partial solutions. We provide tailor-made full-stack solutions on data warehousing, business intelligence, data analytics, and artificial intelligence. Simple, customized, and works like a charm. Contact us today to work with the best data engineers in the region and enjoy your business while we challenge your problems with our differentiating solutions.